Okay, so we're doing just sort of review today with one little bit. So we're going to go to page 594. And now we're going to talk about a general solution. Now, example 2 will show you what a general solution is. So I can use it to teach it instead of all those pages before. Now, first of all, you're going to start doing these, and they look pretty scary at first. Like, huh? I'm supposed to find x from that thing? But if you do a little algebra, you'll notice one thing all the time. So what I'm going to do is I'm going to add root 3 to both sides. So I would get 2 cos x equals root 3. Then I'm going to divide by 2. Cos x equals root 3 over 2. Hey, that's kind of cool. That's on the unit circle. Okay? And right now you should know the answer. Okay? Now I do want you guys to still be in the habit of putting cast down. I've just finished marking your exams, and some people are putting, like, if sine is in the fourth quadrant, you're forgetting your negative sign. You should look back. Is that supposed to be negative there? Yeah, it is. It's only cos positive in quadrant 4. So get those things in. Now, where is cos x root 3 over 2? We got one of them was pi over 6. Where's the other one? 11 pi over 6. Now, right from this, you are done. And if any of you guys take diploma prep, and I've never taught it or taken it myself, but I've students come back and they're like, they don't use unit circle. They like figure out everyone. It's like so annoying. You just sit back. Why don't you just say it, okay? But this is how it's going to be done if you take a diploma course. And that's okay, because I would like you to do this maybe your second time through. But what you want to do is, remember, do this, and you will get the reference angle pi over 6. Now, most likely, you might do that in degree mode and get 30 degrees. Now, where is cos positive? It's positive in quadrant 1 and 4. You do your 2 reference angles, right? 30 degrees and 30 degrees. And then you go find your rotation angles. Now, that's slower, but it is a good second time through, because maybe you had to do those 3 steps on a couple questions before. So if you use those 3 steps in another part, and you do it, and you're like, oh crap, I was doing negative root 3 over 2, right? That's got to be absolute value. I remember that. Okay, good. And then you go back and fix another one. Okay, happens all the time. So, can you just use your unit circle? Yes. And I could tell easily on the people when I did mark the written response. I knew who knew their unit circle, and I knew who didn't. Okay. Now, for the next 2 weeks, because we're going to be done notes next Friday. I'm done in May. Okay. Now, I'm going to challenge each one of you to do 1 unit circle a day. So before you go to bed, whatever. Now we're talking 2 minutes. That's all I want you to do. Draw a unit circle. That's it. I probably wouldn't do it right before I go to bed, because that's all you're going to be thinking about the whole night. You're going to be dreaming unit circle. Okay? So, but it's 2 minutes. Sit down, do unit circle. You're watching your buddy play soccer, whatever. For 2 minutes, do a unit circle on your phone, whatever. Draw it out. I want you to know that unit circle perfect for the next test and for the diploma. But if you did it once a day, then you don't forget it. And it's easier if you do it once a day. Okay? Now, we are still not done this one because it asks for the general solution. So the first thing you need to do is you need to find what is the solution over 0 to 2 pi. You must do that first. So this is called step 1. And if you look up here at step 1, it says solve the equation where the domain is 1 period. Okay? So what I did was I did this. That's the answer for that. The general solution wants this. So the general solution is I want this thing to go on for infinity both ways. So the first thing you do is the red part, second thing is the blue. Now, what I'm talking about is here's pi over 6. If I want to get the next time this happens, what do? What would I do? Add 2 pi to it, correct? So I'm getting all the what type of angles? Nice. All the coterminal angles for this. So all you do is you go pi over 6 plus 2n pi. You see how I'm going to keep getting every coterminal, and then 11 pi over 6 plus 2n pi. N is in the integers. That is the general solution. So number 2 is kind of new, but we've done coterminals before. See, now I've got every angle in the entire world. No, because integers are -1, -2, -3, -4. So it gets all those when you put -2 for your n. Does it make sense? Yep. This is that's this part, and all of this is this part. Okay? So that's your new thing today. Now, let's talk about some kind of different cases where, see, for what we're going to do is for sine and cos, you're going to add 2n pi. For tan, it's going to be pi. Okay? Just like, because pi is 1 period for tan. So, again, remember this stuff. Now, let's talk about sine x equals 0. Now, a picture is always worth 1,000 words, right? So, where is sine x equals 0? Come on, unit circle people, let's go. Where is it? Pi, 2 pi, also at 0. So, step 1 is do it within 1 period. So that happens at 0, pi, and 2 pi. Now the general, you could go 0 plus 2 pi, pi plus 2 pi, and 2 pi plus 2 pi. There's actually a nice way to be able to say all of that at once. Now looking up here, how could you say all of those without having to do 3 different situations? No, we'd still have to use plus something or whatever. Good. N pi. N is in the integers. We usually don't say pi n, but I wouldn't mark it wrong on a test. That's for sure. Okay, so n pi and n is in the integers. So if n is a 0, do you see how I get that first one? If n is a 1, I get the second one. Anytime it looks like what I call a propeller. See, propellers are always like this. Do you see how The question I did here, that's not a propeller. Propellers are from the center right across from each other. Okay? And you can see this one makes a nice propeller, right? If it's attached here, the blades, it makes one long blade. Okay? So tan does that in, like, you know, if you had another situation would be tan, say the graph is like this, right? That was the graph. Well, do you see how that's pi over 4 plus n pi, right? So if you add pi, you get that one, 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 add pi. So this would be, say, pi over 4 plus n pi. And remember, n is in integers. Because tan makes a propeller often. Yes? So when tan x equals sorry, right over there. Yes. Had me messed up because that was a while ago. It's like, what? Huh? That's good. Thank you. Okay. When does cos x equal 0? Yeah, be more specific. See, we got a propeller situation again. Okay? So between 0 and 2 pi, because remember, this is between 0 and 2 pi, right? So let's do that first. So between 0 and 2 pi, we have pi over 2 and 3 pi over 2. And that is between 0 and 2 pi, right? So what would the general be for that one? This is general. The general for this one? I'm not giving it to you. Pi over 2 plus n pi. N is in the integers. That will give you every time cos x equals 0 from infinity to negative infinity. Okay, now what if they give me a restricted domain? In other words, they're telling me where I'm allowed to play. Okay, it's only going to be in these specific areas. So what you want to do is you want to solve it for the one period again. Then you're going to add or subtract multiples of that period to get within that domain. Okay? So, something wrong? Okay, I didn't mess something up though. Okay, yep. With cos x equal 1? For cos x equal 1, it would be this. Because this is when cos x equals 1 as well. For this one? Well, if you made n1, it would give you this one. Oh, this one, sorry. If you made this 0, it gives you this one. But if you add 2 pi to this, you get 3 pi over 2. If you put a 1 here, get that? Because this is, if I put a 1 here, this is the same thing as 2 pi over 2, correct? So 1 pi over 2 plus 2 pi over 2 is 3 pi over 2. Okay, this one here. Okay, no look scary, do a little algebra. I'm going to do 2 sine x equals root 2 sine x equals root 2 over 2. Hey, that's on the unit circle. Nice. Okay? So if you know a unit circle, this is easy. Where is it? Talk to me. Pi over 4 and is that right? No. Sign would not be. This is cast. So we have to be out of those two. So that's where we get our pi over 4. Oh no, actually this is in degrees. So what would it be in degrees? 45 degrees and 135 degrees. Now, look. It said, I want you to give me all the answers in here and here. So this one is not big enough. What we need to do is come around again, and do you see it'll be in there? So if you add 365 to this, because that is one time around, remember, plus 2 pi or plus 365. Yeah, you add 1 year, and you'll get your, okay? So if you add 360, I wish I wasn't taping this stuff. If you add 360, you will get 405 degrees, okay? Now add 360 again. Does it keep me within 720? What happens if you add 360 again? It's over 720, so you don't have to do that one again, but you do want to keep trying that. Now, if we add 360 to this, you should get 495. So these are your two answers, actually. Now, trust me, this would be probably one of the biggest choices picked on the multiple choice, because people won't look at this. They're like, oh, unit circle, that's so easy. This Trimble said if I know the unit circle, it's going to take like 2 seconds. And it did, yes. Okay? This one's going to take 4 seconds, you guys, because you have to read. Okay? Especially us guys that never read instructions, okay? This is what we need to look at. Okay. This one here, well, it's minus 1. So cotan x equals negative 1 over root 3. Cotan. Now, what I could do with this is the same thing as 1 over tan x equals negative 1 over root 3. So what can I do with this? Flip them both, right? So tan x equals negative root 3. Hey! What a coincidence. That is on the unit circle. Now, I know the unit circle looks like this ominous thing that you have to memorize, but it is a tool. Like anything, there's going to be that hard part you got to put in at the beginning, and then you're like, I'm glad I know it. It makes life a lot easier. Okay, but it's getting the work done to get there. Where does tan x equal negative root 3? Now, first of all, I am going to get out of here and here, correct? Because tan's supposed to be positive in those two quadrants, so it's not in those two quadrants. So where is negative root 3? Where is it? 1, 2, 3. 2 pi over 3 would be, so that's 4 pi over 6, right? So that's bringing me up here at 2 pi over 3. And the other one is bringing me over down here, and that's 10 pi over 3, 10 pi over 6, which is 5 pi over 3. Now, that is between 0 and 2 pi, correct? Looky. It does not want me in there. It wants me between negative pi and 0. Now negative pi is right here. So what is the answer that is between negative pi and 0? But 5 pi over 3 is not in here. Very good. Negative pi over 3. I believe this is a great diploma question because it really makes you know, oh, I got to go negative direction for negative angles. So the answer is negative pi over 3. Okay? Now, there is a lot of confusion that people still have. I want you to go to the very bottom. Just hit extend page and it gives you a lot more paper. Okay? There's something that I had students in the first class. They really helped. They really said, I'm getting all this messed up. Okay? So I want to talk about if I gave you secant pi over 3 equals x. Now, remember what that study sheet is for. It is to differentiate. Okay? Now, how would you solve this in your calculator? That's an awesome question, is it not? Sorry? Yeah, this is the same thing as 1 over cos pi over 3 equals x. Not 1 over cos, or no, I should say this. It is not cos 3 over pi, and it is not 1 over cos 3 over pi. Now, what if I gave you something like this? Cosecant x equals 2 over root 3. Now, do you see how these are starting to get mixed up with the other ones? Because people are like, what? Like, which ones do I flip? Okay? How would you solve this one? This is the same thing as 1 over sine x equals 2 over pi over 3. Do you see I haven't changed the question at all? Because cosecant means 1 over sine, which is, so sine x would be root 3 over 2. Hey, it's on the unit circle. Okay, so here's the rule that I need you to know, kind of need you to know for yesterday too, but you never flip the angle. Well, we went through this. It's just some people are still... What's that? Now, there's two comments that I got yesterday when people would come and they would say, this question, I did it this way, should I have done it that way? And I said, no, but it was in radians, so the answer had to be in radians. And they're like, oh crap, I have that on my study sheet. Or the second comment was, oh, I didn't even put that on my study sheet. Okay? Now, these are things that really, and rules to write yourself that really help you with this stuff. If you ask any math teacher in Edmonton Public, what do you think the students have the biggest problem with? They're mixing stuff up all the time, right? So that's why I started getting my students to use the study sheets. Okay? You need to, A, do a good study sheet. Like we learned some new rules today. Get those done in a study sheet. And B, learn it well. Now, all of you have a photographic memory. Believe it or not, you do. What, speaking of marathons, one marathon I had to train for, and it was through the winter, and it was really, really icy, and I was training with a friend. It was so icy out, you couldn't even walk on the sidewalks. So we're like, and we had a 20-mile run to do that day. And we're like, what are we supposed to do? So we actually went to the kitchen and hit 2 treadmills. Now, if you do not know the definition of boredom unless you've run for 3 hours on a treadmill. Okay? But one thing we did to pass time is there's like a magazine there. And one guy would get the magazine for like, he could look at he found the picture and he would look at that picture for 5 minutes. Okay? Then the other person would take it and ask questions. Like how many people were, smoking a cigarette? How many hats were there? What was the house number? What was the model of the car? The guy with the hat on, the cowboy hat, what color is his pants? Now, it was fun because after the first time, you're like, okay, now I know what types of questions he's asking or whatever. So when you're studying the picture, you're making some connections. You're thinking of the questions. And you're like, okay, I know he's going to ask me the house number. It's 128. I know he's going to ask me what kind of car it was. I know he's going to ask how many people are wearing a hat. I'm going to ask, he's going to ask me these questions. So you start anticipating the questions while you're doing it. And it does really pass time. And if you are, say you are like, going on the spin bikes or whatever, and you want to do the spin bikes for an hour, do it with somebody and actually take your study sheets and you ask them questions on their study sheet. And they will know that well. And actually, that's the first time that I ever did a study sheet. I remember beautiful summer, it was beautiful out, it wasn't summer yet, and we had exams coming up, and it was social, I remember, seriously, playing basketball, we were shooting hoops, beautiful sunny day, and we were studying at the same time. Because you're asking stuff off the sheet, because like I said, you guys, there's no way you hate studying as much as I do. There's no way. So I was like, how can I I actually felt like I was truly, truly studying while I was playing, shooting hoops. And I was, like, I knew that stuff. That was the first time I ever used one. I was very successful with it because of all that. And, be creative even when you're doing this stuff. Like, say if you have a car ride or whatever, get somebody to ask you questions about and you will have that thing so awesomely memorized that you'll really do well on if someone was just asking you angles on the unit circle, can you do it, can you do it, can you do it, right? That's how you know you're ready for a test. Okay, so we're doing 1 to 6, 9, 10, 12 to 15. I even taped all that and made those people wait till they get their homework. They had to listen to all that. Just see people dragging the little bar. Oh, he's still talking? Dragging the little bar. He's still talking? Okay, you'll get your homework done today.